Okay, let's look at question number 30. Okay, I think let's explain the idea of ambiguity time. Because the clock is designed in such a way that this is the hour hand and then this is the, let's say, minute hand, but they are exactly the same length, right? That's the reason why it says that the clock shown can be approximately 7:23 p.m. That means if this is the hour hand and then this is the minute hand, therefore it will read 7:23 p.m., right? But on the other hand, if you read it as this part here, this is the hour hand and then this is the minute hands, then this would be just 4 o'clock and 37 p.m., right? All right, therefore both of these times are ambiguous. All right, but if you look at 12 p.m., it is not ambiguous, because this is the hour hand. Okay, you see that this is the hour hand and then this is also the minute hand, therefore they overlap, therefore it's not ambiguous. They are asking you how many ambiguous time happen in the 12 hours from midday to midnight. Therefore I think we can actually draw it using a graph. Therefore, in this case, I'm trying to explain to you the reading of this graph. Can you see that? Can we put it this way? The horizontal axis is the hour hand, and then the vertical axis is your minute hand, right? And then instead of labeling 0, 0, right? Because we like to label this as origin 0, 0, but we label this as if it was a clock. We label it as if it was a clock. Therefore, this is actually 12 o'clock midday. 12 o'clock midday. All right, and then on the minute hand, this is also 12. This is also 12. Right, this is also 12. Right. Therefore, in this case, can you see that? Let's say you look at this clock. You look at the clock. If it is let's say this is 12 something, 12 o'clock. 12:15. Let's say around 12:15. Therefore, let's say this is 12:15. This is 12:15. 12:15 means in this case is 12 plus, and then this is the horizontal coordinate, and then the vertical coordinate is actually what? The vertical coordinate is actually 3. Therefore, in this case, what I'm trying to say is that you can actually locate this point, right? 12 plus horizontal axis, and then 3. This is the point, right? Then it will go all the way to 1, right? Can you see that? You will go all the way to 1. That means in this case now, I try to look at this point. This is almost coming to 1 o'clock already. Almost coming to 1 o'clock. Let me clean this part here. Let's say this is almost coming to 1 o'clock. Can you see that? This is 12, and then 12, let's say 53, 12:53, 12:53. This is the hour hand, and then this is the minute hand, right? This is the minute hand. 12:53. That means I will indicate this as 12 plus and then 10 plus. Is it okay? 10 plus. Because we follow this marking. Instead of 53, I say that it's 10 plus. Right? Therefore, in this case, can you see that you draw? Where is the point? Where is the point on the graph? It is 12 plus coming to 1, and then it is 10 plus. Yeah, this point. Therefore, that is how you actually get this straight line. Agree now? That's how you get this straight line. As the clock move from 1 o'clock, 12 o'clock all the way to 1 o'clock, right? And definitely there will be some point is the ambiguous case. Take for example, when just now when we look at 12:15, right? When we look at 12:15, it will be like this, right? Can you see that this is 12 and then this is 3, right? But you can also think of it as 3 o'clock. You can think of it as 3 plus, and then this is slightly more than 12, but slightly more than 12, or slightly more than 12, or maybe in this case slightly more than 12. But the slightly more than 12 means that maybe it's 3 o'clock, 3:03 p.m. or 3:03 p.m. and this is ambiguous, right? This would be the ambiguous clock, this would be the ambiguous timing. Right? Yeah. Therefore, what I'm trying to say is that on this straight line here, there will be cases of ambiguous time. Or it may be here ambiguous time, and maybe here ambiguous time, maybe here ambiguous time, and ambiguous time here. Right? Therefore, you need to locate the ambiguous time. All right. And then similarly, now you consider 1 to 2 o'clock, or therefore you join. Then you get another straight line here, right? And then after that, you consider 2 to 3 o'clock. Oh yeah, you get another straight line here, right? Or therefore, you get this 12 straight line. Understand? You get this 12 straight line. Okay, now I'm going to explain to you where is the ambiguous point. Can you see that? This is a coordinate system whereby we draw in this way, right? This is hour hand, and then this is the minute hand, right? Then in this case, the ambiguous time means what? An ambiguous time is the one where your your hour hand and the minute hand are not equal, and then your these coordinates HM and MH are both on this graph, right? And since this point and this point are the points reflected on the diagonal. Can you see that? Let's say in the normal coordinate system, this is XY, right? If I call this point 3, 4, then this point is actually 4, 3, right? This point is actually 4, 3. Do you realize that these 2 points are the reflection of each other about the line y equal to x? It's a reflection. It means in this case, the distance here and the distance here are the same. Right? Therefore, can you see that this is the ambiguous point? You can read 3, 4 or 4, 3, right? Therefore, can you see that since H3 and MH, HM and MH are points reflected on the diagonal, H equal to M, and ambiguous times, the ambiguous time will be a point HM that is on both graph, both on the graph and the graph reflections as shown in part 2. Therefore, in this case, can you see that if you draw the reflection, right? If you draw the reflection of this graph, can you see that? Okay, let's say this is the graph. This is the line 1, right? Line 1. Do you realize that the reflection of line 1 is actually this line? That means, can I call it 1 prime? That means 1 prime. This 1 prime is the reflection of 1. Then similarly, can you see that? This particular point here, can you see that this part here, this is 1, 2, 1, 2. Can you see that this part here, this is 1, 2. This is 1, 2. Can you see that this part here, this is actually 1, 2. This line, this 2 prime is the reflection of these 2. Alright, and the intersection of these 2 points will be the one that give you the ambiguous point. That means in this case, can you see that you are getting the ambiguous point here? Can you see that this part here, the ambiguous point? That means in this case, can you see that what you are getting is this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means from 12 o'clock. That means from 12 o'clock you start. The clock turn a big round, right? There will be 11 ambiguous point before it reaches the 1 o'clock. Understand? Before it reaches the 1 o'clock, right? Therefore, in this case, can you see that? Okay, take note, class. If you include the diagonal, the number of points that are intersection of these 2 graph, which is the graph 1 and also graph 1, and then this is the reflection, right? If you include every points, it will be 144. How do you get 144? 144 is actually 12 times 12, right? But the thing is, there are 12 points that are non-ambiguous. That means in this case, can you see that this diagonal is the one that is non-ambiguous? How do you interpret this non-ambiguous? That means you interpret this as, can you see that this part here, 12, 12. Hour hand and the minute hand exactly 12. This is not an ambiguous time. Not an ambiguous time. And also, just to remind you, in a proper functioning of a clock, you don't see you don't see our hand, at 2 o'clock, and then you also have 2 o'clock here, right? Because that means your clock is not functioning well. Because why? If it is 2 o'clock, if it is 2 o'clock, if it is 2 o'clock 10 minutes, right? If it is 2 o'clock 10 minutes, if it is 2 o'clock 10 minutes, the clock should indicate in this way, right? Let me clean off. Your clock should be in this manner. This is 2 o'clock. Let's say this is the hour hand shorter, but your minute hand, in a normal functioning clock, your minute hand will be slightly out, right? To indicate that it's actually 2 and 10 p.m. 2 and 10 p.m., right? Therefore, that's the reason why all these diagonal are not ambiguous point. Therefore, you must minus away 12. You must minus away 12. Therefore, what you get is 132 points. 132 points, it means that it is actually 122 ambiguous times, Or another way of thinking is that when I show you this 11 ambiguous point, can you see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? That means from 12 to 1 o'clock, there are 11 ambiguous points. But there are 12 hours, right? There are 12 hours. Therefore, it's 12 multiplied by 11. And that is actually 132 also. All right. But I think this is to show you graphically why do you need to minus 12. You are actually minusing away. You are taking away the diagonal points. That's it. Therefore, it's quite a brilliant idea. So that we can actually solve this question quite nicely using graph. I think this solution is the easiest. You may like to take down this solution, but I think I explained the gist of the solution to you already. All right, yeah. Or you may pause the screen and then do a screenshot. All right, with that I stop here.